You're welcome to mutually exclusive events and probability. Mutually exclusive. Exclusive means exclusive. That means only or not part, isn't it? It's not part. Exclusive is not part. So if something is exclusive of something, can you go and take it out of it? If you are exclusive, a payment was made for a party, you are exclusive, you didn't pay for the party. Can you go and take your money out of the bill? No. So mutually exclusive, that means it's not inclusive, meaning there's no intersection. Now, there are cases like this. For instance, the probability, example, if the probability that x equals 0.3 and the probability that y is also equal to, let's say, 0.2, find I p probability of what? Find the probability of x intersection y. I find the probability of what? X union y. We are referring to set over here. So if you watch the video on set, this will not be a job for you. It will not be any work at all, because it makes sense. Now, we said mutually exclusive. So the examiner will tell you that this event, if x and y are mutually exclusive, so respect that English. I've told you masses English you respect. If you respect the English, you are free. Mutually exclusive, so respect that English. It means there's no intersection. It's exclusive. It's not part. Therefore, you can't subtract. And if it's mutually exclusive, it means that intersection is equal to null set. Is it interesting? It's null set. It's empty. It's exclusive. If it's exclusive, it's not there. So you can't get it. It's not zero. It's null set. Empty set. So respect that English and apply that. Now he has to find x union y. Probability of x union y. Meaning probability of x union y is equal to what? Probability of x plus probability of what? Y. Is that not the case? Because we said union is what? Addition. I told you in the set that when it comes, we use union as plus, and union means unite plus. So that's the case. So what does it mean? The answer is, what's the probability of x? 0.3 plus what's the probability of y? 0.2. So at the end of the day, 0.3 plus 0.2 gives you 0.5. This is your final answer. Simple. But if the question was silent, or the question has said mutually exclusive, meaning there is intersection. So let me use the same figures. In that case, this is what is going to happen. Let me finish it, then I'll come to the union. Find y, x intersection what? Y. Probability of x intersection y. Meaning there is intersection. And intersection is probability of x multiplied by probability of what? Y. Why do you use multiplication for intersection? Multiplication, intersection. That means intersection means you are doing the same thing at the same time, or you are taking part at the same time. You are here and at the same time there. Inter, meeting point. At what point will you when you are doing two things, meaning you are bringing multiple effects? True of us. You are in A, you are also in B. You are having multiple impact on the game. You play volleyball. I think when you were in school, some played volleyball at the same time, played what? Basketball, or play football at the same time, two or more. That means there's multiple effects. They have multiple effects on the games we were playing. So if there's multiple effect, then we should use multiplication. Does it make sense? Multiple effect, multiplication. So intersection is multiplication. So when you ask to do, so let's see, so we got 0.3 times what? 0.2. Multiply it. That will be your answer. 3, 2 will give what? 6. How many decimal places? 2 decimal places. So you get what? 0.06. Is that correct? Because if you have 6 and you have 2 decimal places, you move 1, 2, 0. So 0.06. That's the answer. How did I get it? I didn't use calculator. Follow that math. You work it better than myself. I'm telling you. Follow that math and watch our videos. So that's the case. So when there's mutually inclusive or the question is silent, then it's multiplication. Multiple effect. So intersection has multiple effect. You are here and at the same time there. So you have multiple effect. That's the case. Now, in that case, when the question is silent or you say mutually what? Inclusive, what will be in union? So you see, probability of X union Y is equal to probability of what? X, because union is what? Addition. Plus probability of what? Y. Good. Over here, when we did say, we saw that for union, you must subtract the intersection. Do you recall that? Yes. Those who do mathematics, those who do English, before to get mathematics and English only, you must subtract the intersection. So to be minus probability of what? X intersection Y. So when the question is silent or you say mutually inclusive, you must subtract the intersection. But mutually exclusive, there is no intersection. It doesn't exist. It's empty. So you don't subtract. Have you gotten a picture? So at the end of the day, your answer would have been what? What did you get for the union? You got union as what? 0.5. So minus and intersection, you got it to be what? 0.06. So 0.5 minus 0.06. You can do your calculation. That will be your final answer. Let's see. 0.5. So this is 0. 0.06. This is what? 10. Supply got what? 4. This is what? 4. So 4. 2.0. So you get 0.44. That will be your probability. So the probability that of what? Universal set or union set when it's inclusive or silent is this way. So that's the end of mutually exclusive event. So respect the English. Now let's do this one, then we conclude. Let's do this one, then we conclude. Then the rest will be logic. As you follow our website and watch all the videos and the probability, you get it better. Series of questions have been answered in the video form like this for you to understand better. Now let's talk about dependent and independent events. Dependent and what? Independent events. Once you depend on someone, what does it mean? It means you rely on the person. What happens to the person affects you. True or false? If your father takes care of you and he loses his job, excuse me to put it that way, what does it mean? It will have an effect on you. So what happens to you happens to you. But as for independent, that means you are not, what happens to somebody does not affect you. What happens to your father does not affect you because you are independent. You don't depend on anyone for survival. So that's the picture. So that one is a normal probability you apply. There's nothing to add up. So let's see that type. So mutual when there's independent. So a question will go like this. Right? A ball contains yellow ball. Maybe yellow balls are 4. Green balls are maybe 3. And okay, green balls are 2. Then we have blue balls to be how many? 5. A bag contains this ball. Identical ball, different colors of this nature. What will be the total sample space in this case? Yeah, these are all the balls. What will be the total? I believe you remember that total sample space will be equal to what? 4 plus 2 plus 5 equal to what? Will it be 10? 11? It will be 11, right? Let me change this one to 3 so that to make our work easy for us. So this is 3. Good. 3. So 3 plus 8 give us what? 10. So this is the total sample space. Then the question will ask you that if this event, all a ball is selected at random, or 2 balls are selected at random, one after the what? The other. Listen to this carefully. and they depend on each other, right? Or the examiner will say without replacement. Very simple. That means without putting it back. That's the dependent event. Without putting it back. What does it mean? The ball, if you pick one, it will reduce to 9. Do you agree with me? After picking the next one, it will reduce to what? 8. So, what is the probability that probability that, for the sake of time, let me put it this way. Probability that the two of them are green. So listen carefully. 2 are green. The two are green. Good. So what it means that green over sample space. Do you agree with me? First one is green. And is at the same time because experiment is happening at the same time. So first one is what? Green. Second one is also green. Now, the second person picking, if you are picking the second one, which is green, the number of green will remain 1. And the total will remain 9. Do you agree with me? That's the dependent. Because green were 2. The first experiment, you didn't put it back. So after that, you put it in your pocket. You took it away. So remaining 1 green. So you write 1. The total has also reduced by the number of green because you didn't put it back. So it remains what? 9. Doesn't make sense. This is the dependent event. So at the end of the day, your answer is what? 1 times this will give what? Get 2 over what? 2 times 9 is what? 90. So 1 here, what do you have? 1. Then here what? 45. This will be your answer. Last one, then we go. Probability that first is green, and second is yellow. What will happen? First is green, so green over total. Forget about this. We are done with this. So we are starting the experiment all over again. So first is green, so green is what? 2 out of 10. And so the 10 is happening at the same time, so it has multiple effects. So you multiply, that's why you multiply. And the second one is what? Yellow. Second one is yellow. Yellow is still 3 because what you picked was not yellow, it was green. So yellow is still 3. But the total remains 9. Do you agree? Yes. Because you have reduced this one by the 1. That is the case. You watch the video, you see more examples on that. So now 3 will cancel here, 1, 3 here, 3, 2 here, 1, 2 here, 5. So how did they get what? 1 out of what? 5, 3 is what? 15. That will be the answer. And for that matter, that's the end of this lesson under probability. Watch more videos from the native website and you get more examples solved for you to understand better. Love you.